All right, so today we're doing the permutations and combinations unit. It's a unit with a lot of different types of problems, and coming full circle, when you go to your unit test, you got to ask yourself, obviously, what strategy to use in what situation. And generally, it comes down to, does order matter? So we'll look at that here. I'm going to look at 3 different problems where you're not going to exactly know right off the bat what strategy to use. The one I've chosen originally, I guess there is not really much choice here. I picked this one because a lot of students struggle with this and have mentioned to me that they find this confusing. Here, there should be no question as to what strategy you're using. You're just solving this equation. There's nothing tricky about it other than knowing what strategy to use to actually simplify these things. So you need to be able to simplify this first, and what that's going to mean is finding something in the top or the bottom to cancel out. Now remember, with factorials, you go down by 1. If you keep going down by 1 here, you're going to get -3, -4, -5, and none of those things cancel with n factorial. However, on the top, if you break this down to n-1, n-2, that will cancel out. So we're going to make the top n-1, n-2 factorial, knowing that this n-2 factorial is going to cancel out. Okay? So that was your first step, is you had to be able to simplify. If you can do that step, then you can move on to the next step. And what that is when you cancel that out, you're left with this. This is actually a quadratic equation. So you want to multiply the n into both terms. It's called distributive property. You get n squared minus n equals 240. You want to move everything over to one side of the equation to work with it. And this is called a quadratic equation. As I said, it's degree 2. You're going to need to be able to solve this. And you did do that last year. Whether or not you remember is another thing. But I'll show you here how we can solve this. You basically have 3 options. Factoring, 2 numbers that add up to the middle coefficient and multiply out to this last number. That's hard in this case. You can use your graphing calculator, or you can use quadratic formula, and that's what I'm going to do here. Quadratic formula is on your formula sheet. It's negative b plus or minus square root of b squared minus 4ac all over 2a. If you're wondering what all those letters are, they're just the coefficients. So here, this is a 1n squared. There's 1n squared. There's -1 n's, and there's -240 single 1 numbers on the end. So this is my a, this is my b, and this is my c. So I'm going to go into my formula here. Negative b is going to be just 1, because b is -1. Okay? Plus or minus b squared. It's a -1 squared, put brackets around it. That's a mistake I see a lot. A is 1 and c is -240. Okay, all of that is over 2a, which is just 2 times 1, because a is 1. We just have to simplify this now, and if we don't make mistakes, it'll tell us our solutions. -1 squared is 1. -4 times -240 is positive 960. So you've got a positive 960 for this term, and it's all over 2. If you simplify that on the next step, that's 1 plus or minus the square root of 961 over 2. And the square root of 961 is actually 31. So this breaks down to 1 plus or minus 31 over 2. And that gives you 2 solutions. The first solution, which I used to show my students as x1, is going to be 1 plus 31, which is 32, divided by 2, which is 16. That's one of the solutions. Quadratic equations often have 2 solutions. The other one, 1 minus 31, is -30. -30 divided by 2 is -15. So you actually get 2 solutions to this thing. In most cases, we're going to use the positive solution. So in this case, x equals 16. I know that I all of a sudden switch from n's to x's. It doesn't matter. It's the variable you're using. So the solution to this thing is n equals 16 is the value that solves this equation. Okay, so the next problem we're looking at here is dealing with committees. I've said this before. You got to ask yourself, does order matter? When you select people on a committee, does it matter the order you select them in? Does it matter if it's Bill, Joe, and Steve, or Joe, Steve, and Bill? Generally, the answer is no, meaning it's a combinations type question. You have to be able to know what to use when. So this is a combinations type question. It's not guaranteed to be, but if you see the word committee, if it's a question about a committee, 95% of the time it's a combinations question. Now the question here has the word at least. That's the key words here. It wants us to form a 5-person committee, so we need 5 people. We're picking from 6 women and 4 men. But the key thing here is at least 3 men. So we need a committee with 3 men or with 4 men. We can't do 5 men because there aren't 5 men available. So we need to actually do 3 men plus the option of 4 men. And this is, again, tied to that word at least. We're using combinations. So from the 4 men available here, we're choosing 3. But you need to remember to take care of the women too. That's only a 3-person committee. So from the 6 women, we need to choose 2 to fill the committee. That's a 5-person committee. For the 4 men, that's going to be 4 choose 4 because we're taking 4 men from the 4 available. And then for women, from the 6, we're choosing 1. Okay. You put those in your calculator. This comes out to a 4. This comes out to 15. This one comes out to 1, and this one comes out to 6. If you tally those all up, you're looking at 60 plus 6, which means that you could form this committee in 66 different ways. Okay, so again, if you knew what to do on this type of problem, it's easy, but obviously what makes these problems harder is, yeah, you need to pick from a number of strategies. All right, this is the last question I'm going to look at. We're dealing with arrangements of the letters in the word Canada. So if you're arranging letters in the word Canada, A, no restrictions. B, we do have restrictions. Okay? So if you take the word Canada, it's 6 letters. So normally my first guess would be, all right, it's 6 factorial. 6 times 5 times 4 times 3 times 1. The only thing is there's 3 A's. So you've got repeated elements. What that does is any arrangements you make where you switch 2 A's around, they look identical. So we don't count them. So we have to divide out those combinations we make where they have the same, they look the same. So for A, if there's no restrictions, we've got 6 letters, so that's 6 factorial. But we need to divide by 3 factorial. Why? There's 3 A's. Any combinations you're making with the A's, if I switch these 2 A's around, it's going to look like the same combination. Right? So first, in A, that comes out to 120 options. In B, they've given us a restriction. So they're telling us that it has to start with C. 1, 2, 5, 6 has to start with the C. So we're down to 5 letters. So you'd have 5, 4, 3, 2, 1 choices on the end. The only thing you need to consider here is, again, if I set it up like this and I say, all right, there's no choice here, 5, 4, 3, 2, 1 for the rest, I'm not taking into account that of these remaining letters, I've still got a bunch of extra A's. Now, if this was an A, I'd be down to 2 A's, but I still have 3 A's available for all these. So my actual answer is going to be 5 factorial as it's written here, but there's still a 3 factorial. There are still 3 A's available. Okay? So our answer here, 5 factorial over 3 factorial is just 20. Okay? So those are 2 typical problems that you would see. In this case, we used permutations. Order mattered, whereas in the last question we used combinations where the order doesn't matter. Hope that helps, and I'll see you guys next time.